This time, the Planet Mechanics are down by the sea.
It turned out nice! I can't actually see.
Getting to grips with the force of the ocean. But this is no surfing safari. They want to use wave power to generate electricity.
Oh, okay, let's speed up the measurements.
So, will it be plain sailing?
What's to go wrong?
Or will it be a wipeout? Dick Strawbridge is an ex-army officer turned eco-warrior. Jem Stansfield is an inventor with a wild green streak. Two men on a mission to fix the world. One mechanical solution at a time. Together, they are the Planet Mechanics. Dick and Jem's eco-engineering trek around Europe has reached the Emerald Isle.
This is glorious. That's my picture of Ireland.
Travelling in their trusty horse truck turned mobile workshop, they've come to County Clare on Ireland's west coast.
Hey, look, there we go, the Atlantic. That's Galway Bay. And this is pretty amazing scenery. But apparently up here, where we're going, is even better. It's got a reputation for being something special.
This rugged coast has been shaped by the sea for hundreds of thousands of years. And where Dick and Jem are heading, nature has created something truly awesome.
Look at that for a view!
Whoa. That's amazing, isn't it?
At 214 metres, the cliffs of Moher are some of the highest in Europe, and they bear the full brunt of the ocean's force.
Imagine the battering those cliffs must have taken to end up looking like that.
But the waves have got the whole Atlantic to build up before they hit it.
That's just incredible.
With an uninterrupted expanse of sea stretching out for thousands of miles, the west coast of Ireland gets some of the biggest waves in Europe.
Makes you want to go and play with it, doesn't it?
Yeah, just not too close to the edge.
For our eco-engineers, the immense power of the sea spells opportunity. The ocean is a massive source of free energy. However, the ravages of wind, wave and salt water make tapping into it a daring undertaking. Nevertheless, Dick and Jem are up for the challenge. But they're not the only ones around here who are interested in big waves. And the Planet Mechanics are keen to recruit some of them. Meet Keith and Rosie. These surf buddies tour Ireland looking for the best waves to ride. They're just along the coast from the cliffs, surfing the beach break at Lahinch.
Surfing is my life, pure and simple. Surfing's my life.
It's a way of life. It's not just a sport. It's hard to describe, and he knows exactly what I mean, but I can't describe it to him.
On a good day, it's great. It's just really cold.
Dick and Jem know that the waves can be harnessed for green electricity. It's been calculated that the sea around Ireland contains enough energy to generate over 18 times more electricity than the entire country needs. So with a few days and some simple resources, Dick and Jem want to work with the surfers on a test project that will actually show how the waves could be put to work.
You into this surfing like, mate?
I don't mind a bit of surfing myself, Dick.
It's quite hard work, but isn't it?
It would be tricky out there today.
Hi, how you doing?
Rosie,
How's it doing? Not a bad place to be, is it?
that's very, very good today.
Nice.
The waves are big.
So what exactly can we do for you?
Well, there's waves, and we would like you to power our surf shack.
What's your surf shack like?
It's a surprise. Do you want to see it?
Too right, I want to see it.
A surprise.
To see how wave power could work for Keith and Rosie, they all head back to the trendy surf shack.
So, this is it.
This is the surf shack.
This is the surf shack.
It looks a little bit more like a caravan.
It is a caravan.
Oh, that's okay. That's okay. As long as we all know that.
Would you like the guided tour?
Oh, thank you. You've kept it quite minimalist.
This old caravan might be modest, but to our surfers, it's home. At least for the surf season.
So this is the kitchen, dining room, living room, bedroom.
Get a door finish.
Nice tour. I liked it.
Okay, what do you need the power for?
Well, basically lights, obviously, and CD player, you know, and Keith's a musician, so he plays the guitar and he plugs in his
So
amp.
an amplifier would be good for the guitar.
Okay, so if you can have music, if you can have lights, and if you can be sort of playing and dilling on your guitar, you'll be happy.
Yeah.
Dick and Jem want to use wave power to let Keith and Rosie park their caravan as close to the sea as possible and power it in a green way. But that's no easy target.
The waves are probably the most powerful thing we're ever going to come across. Yet, getting energy out of them seems nigh on impossible to me.
Time to make a plan.
To figure out a plan, they return to their own mobile home from home and set up base camp at a nearby farm. Once, this was a livestock transporter. Now, it's a fully equipped, environmentally friendly workshop.
I have it.
With biodiesel in the fuel tank and wind and solar power for the tools, it's got everything they need.
Keith and Rosie were really cool, and what they want in energy requirements, I don't think is asking too much.
Yeah, but the fact they want to get energy from the waves, that's difficult.
With so much free energy on offer in the ocean, engineers have been trying for many years to harness it. But the destructive force of the sea has wrecked many a design.
There is no established wave energy converter out there. I think we need a stack of experiments.
Should we go to the lab?
Yeah.
Because no one design for a wave-powered generator has emerged as the best, Dick and Jem want to look at some of the strongest ideas. Three rough and ready models will help.
Sure, you've got everything there, mate.
Yeah.
Should we do the saltless duck first, mate?
Okay.
Number 1, Salter's Duck.
Okay.
Well, you can see how it bobs up and down like a duck. But I think that's the easy bit. Even ducks know how to bob up and down in the waves, but it's turning that bobbing into electricity.
Developed in the 1970s, the Salter Duck was one of the first ever wave-power devices proposed. It was a very efficient design, but required complex mechanisms to convert bobbing into electricity.
I've got my wave snake here. As the wave ripples along there, all the pieces move relative to each other.
The Sea Snake device is more recent and has proved a more straightforward way to produce power. It uses long hinge segments that bend up and down and pump liquid through a turbine connected to a generator.
Having that out at sea, you just know it's going to end up on the shore.
But I feel it's more robust than the wave duck. I love the idea. I think it's a beautiful plan.
Right, next. Oscillating water column.
Okay, I'll make a wave.
You can hear the water.
Move up and down as if we had big waves.
Yes.
The oscillating water column makes electricity by taking the movement of waves inside a chamber and forcing it upwards through a wind turbine on top. All three of these wave energy converters could work in the seas off Western Island. So to select one and pinpoint a location for it, Dick and Jem revisit the shore. But no one's told them how quickly the weather can change around here.
It turned out nice.
Look at our bath. This looks like the most ridiculous representation I've ever seen.
That is impressive.
I can't actually speak.
Right, there's no way we're going to anchor anything out there and make electricity, mate.
Look, I can't even stand here for very long.
The conditions only a short way offshore are wild. It's simply too fierce to even consider anchoring a structure out at sea. Dick and Jem may be out of their depth.
We're going to have to go to the shelters up here over here.
More shelters.
With the Atlantic Ocean giving a mere glimpse of its strength, Dick and Jem can see why harnessing wave power has proved such a fiendish challenge. But this more sheltered harbour wall has given them an idea.
There's no way we're going to anchor anything offshore, is there?
That looks closer to being feasible. The way it's sucking up and down the wall, it really lends itself to one of those oscillating water columns.
Should we have a close look and see where we can put it?
Yeah.
They think an oscillating water column, like a giant version of the bucket with the fan on top, could be bolted to the concrete pier and be the best way for them to turn waves into electricity. However, taking on the Atlantic Ocean in October is going to test them to the limit. So they need to come up with a design that really holds water. Back at the horse box, a plan is emerging.
If we're going to use an oscillating water column, we need a big tube for the waves to go up to oscillate.
Yeah. Now I've seen the size of the bath we're going to have to put it in. It shows us the scale we're working on.
So our starting point, a big tube.
Okay.
They want to attach a large vertical pipe to the pier wall, but it's going to need firm fixing.
A phenomenally strong steel frame bolted to the side of the pier.
Need a funnel on the top. The funnel at the top is going to allow us to have lots of speed in our wind, isn't it?
Put a turbine right there in the neck of the funnel.
Yeah.
Starts generating the electricity.
The oscillating water column will consist of a large tube mounted upright on the pier. The waves will slosh around inside and create air movement in the space above. By placing a funnel on top of the tube, they will close down the airspace and increase its flow speed. The rush of air will spin a wind turbine and generate electricity for the Surf Shack caravan.
The genius of the oscillating water column is that all the clever stuff, all the electricity, all the moving parts are well out of the water, up there in the fresh air, which means the only thing in the water is just a big fat tube. What's to go wrong?
They'll need permission to use the pier, but by building this prototype in the centre of the community, it will also help spread the word that wave power is a realistic green technology. Later, with the full go-ahead from the local authorities, Dick and Jem head to the pub to pitch their plan to the surfers.
The waves here in Dillon get really big, but will that invention withstand the power of the waves?
How bad does it get?
Really bad.
Yeah.
It's nice and positive.
Keith and Rosie think the lads might have underestimated the force of the sea.
Like, even when they're not big, they're still powerful.
Though other than it getting smashed to smithereens, have you got any other doubts?
No, not really. That's the main thing. It has to be built like a tank.
Right.
Okay, Jim, that'll do for me.
The surfers have serious concerns about whether the oscillating water column will last the distance. But Dick and Jem thrive in the face of adversity and are confident they can pull this off. Next day, there's just enough time to conduct some last-minute research into waves. Dick and Jem want to experience for themselves the power of the sea. So they've come to meet Irish champion surfer John McCarthy.
Okay, what's the surf like around Ireland then?
Probably the best conditions in Europe today.
Today?
Is that good here?
Yeah.
What's the most powerful wave you've seen off this coast?
The waves in winter time, when you get a big Atlantic swell, you can get 80-foot waves here. So, you know, so we're not going to put you through that.
Why not?
We'll focus on the 2-foot waves today.
What's the biggest wave you've surfed around here?
Probably maybe 35-foot waves.
The Cliffs of Moher, 2006. This is John showing exactly why he's a champion surfer.
I'm sick of us being with people that are cooler than us. Why don't we hang around like some computer college?
Okay, hold on. You know,
When they get over that side, it's usually with a big storm and a big wind, so you don't really get a chance to ride them safely. And the likelihood of like a 40-foot wave coming in today is probably only 1 or 2%.
I'll take them odds.
The Planet Mechanics hit the surf. Dick might be struggling to catch one, but the waves hitting the west coast of Ireland are some of the best. And Jem is making the most of them. The sheer size of the Atlantic Ocean means these waves are a consistent, year-round fixture, just waiting to be tapped and turned into electricity. Powering a caravan with a prototype wave converter could be just the start of what's possible here. After 2 hours in the sea, the lads are shattered.
Enjoy it. amazing.
Takes it out of you a bit.
Yeah, the waves have got all my energy now as well. And you just can't believe how hard they hit you when you get it wrong.
It's impressive, isn't it?
With personal experience of the force of the sea, Dick and Jem can now really see that their oscillating water column is going to take a battering. Waves hit Doolin Pier at roughly 10 to 20 miles per hour. With each cubic metre of water weighing 1 tonne, a large wave could do some serious damage. So whatever they build their prototype with, it'll have to be tough. They're first going to need a large pipe to form the main water column of their device. And at a nearby contractor's yard, there's plenty on offer.
These are thick.
Does this plastic sewer pipe fit the bill?
Yeah. Is that strong enough?
I don't know, in all honesty. Oh, it's heavy, but it's not too bad.
Do you reckon we can manoeuvre this on the pier?
The pipe is fairly light for its size, so fixing it to the pier won't be a problem.
You can just picture this vertically with the waves coming underneath it, all the water being pushed up to the top. I like that. That'll do us, won't it?
Yeah, I'm sold on it.
The surplus sewage pipe will become the key element of the oscillating water column.
That was quite a successful shopping trip, I reckon.
It's nice, isn't it?
I think the fact that it hasn't broken whilst being loaded on is a good first test of survivability.
But the pipe has to survive a lot more than just loading on the back of a truck. When a storm hits Doolin Pier, its power can be tremendous. This footage from last winter shows the pier engulfed by waves. In the past, massive boulders have been thrown around by the sheer strength of the sea. It's hard to imagine anything standing up to a wall of water like this.
All right, that'll do it.
To get an idea of the damage even small waves could cause, Dick and Jem are going to simulate a wave impact on a steel oil drum.
Up there, I've got a ton of water. It's about to fall 3 metres. When it lands on that barrel, it'll be going about 15 miles an hour, which is pretty much a similar speed to a fairly meaty 1.5 metre high wave hitting you. So it's not even big.
A great scientist.
Yeah. Well, that
scientist.
bag, we need to find out what kind of forces we're dealing with, and this is the best way I think of doing it.
With everything set, Jem's going to burn through the release rope.
Here we go. Here we go.
It's still smoking.
Okay, that's great. So what are we going to do then, Jem?
The reinforced metal didn't stand a chance.
Pancake?
Are we sure that the tube we want to use is going to survive?
No. Having seen that, I'm a lot less sure than I was before we did that. I think it was well worth doing in that respect.
No, actually, it's worth doing, but what's it proven to us? That we got a problem.
Dick and Jem now have serious worries about whether using plastic pipe for their oscillating water column was the right decision.
You know what we have to do now? We have to test our own pipe and see if it works.
I know, but what if it doesn't?
Using another piece of sewer pipe identical to their own, they repeat the test.
Here we go. You ready?
If the pipe is crushed, it'll be back to the drawing board.
Let's go in. Any second now. Ready? Oh!
Yes! Oh! Oh, you little beauty!
It's safe!
flex a bit. To begin with, it looked like it was going.
It did, it flexed a bit, but it took it.
Although the pipe is only made of thin plastic, the double wall spiral construction makes it surprisingly robust.
See, it was a good experiment. Man, my heart was in my mouth then.
I was worried. I was worried.
It's a huge relief and means that their choice of materials was spot on. But having a pipe that'll stand up to the raging sea isn't enough. It also has to remain firmly attached to the pier. The next step then is to take some measurements for a steel supporting frame.
1.5.
175.
175, cool.
But the tide is starting to rise.
Oh, okay, let's speed up the measurements.
At 1 metre, we're 120 mil.
Unfortunately, they've noticed the wall isn't completely straight. Their frame will have to fit tightly though, so the job turns into a time-consuming survey. At least where Dick can help it.
Yeah,
What's
Dick.
that in inches?
Dick.
Should we try somewhere else and see what about further out?
No, I think we've got all we need. I think the profile's the same all along. Where did I put my shoes? Dick, did you see where I put my shoes?
What's that in the water?
No, you're joking. I'm not an idiot.
The Atlantic may have served Dick and Jem their first warning, but at least they now have an accurate picture of the pier. They can now start building their frame.
Okay, so that's lots of fixings.
Yeah, all the way down the harbour wall. Dunk, 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 dunk. Loads of them.
To increase the intensity of the airflow, a custom-built funnel is needed to cap the pipe.
The waves are going to push air up it. We're going to have to funnel it so that the actual air goes through a smaller area. If we're doing that, the material, something like fiberglass is the obvious way, isn't it?
Fiberglass would be cool. They make boats out of fiberglass.
I hate fiberglass.
As long as you don't get it in your moustache, Dick, you'll be fine.
So
with
who says
fiberglass.
I'm doing it?
Well, I don't want to do it, do I?
Fiberglass might be the best material, but working with it is a nasty job neither Dick nor Jem fancy.
Scissors, paper, stone, mate. 1, 2, 3.
When you do the fiberglass, Dick, wear a mask. Keep it out of your moustache. See you later.
Jem sets to work on the frame, cutting to length dozens of pieces of tough angle iron. Dick's marking up a polystyrene block, the first step of an ingenious method of making a mould for his fiberglass funnel.
Jem, mate, give us a hand, will you?
A bit of hot wire cutting.
Yeah.
Using a heated wire, they're melting through the block to make a cone shape.
Well, we're going to come vertically into 0, and then we're
Okay.
going to go round.
Now we're going to the 1 first. 2:30 now.
3.
They have to move around the circle at the same rate, otherwise the mould will be unusable.
5:15.
5:15.
5:30.
5:30.
Time to find out if it's worked.
Hey! Very good, Dick. Very good. I feel like one of those dogs that's not allowed to scratch.
The hole looks great, but it's the cutout piece that's useful.
Hey, this is good. Look at
Don't,
this. It's a nice mould for the funnel, but isn't it?
don't rub it any more than necessary.
I have to sand it,
No, you
Jem.
don't. Yeah, but
It has to be sanded.
I'm gone. I'm out of here.
The mould has come out perfectly and is ready to be turned into a funnel. So while Jem returns to his steelwork operation, the next job for Dick is his favourite, fiberglass. This stuff actually consists of fine strands of glass, which easily embed themselves into skin. Next comes the resin, a foul-smelling, quick-drying glue that sets the fibres together. Weight for weight, fiberglass has more tensile strength than steel, plus it doesn't go rusty. Looking half like an art installation and half like something from the space race, the mould has to be coated quickly before the resin hardens. Meanwhile, back at Project Metalwork, Jem's getting stuck into a marathon of cutting and welding. As the pieces come together, the structure of the frame starts to become clear.
That's substantial and warm.
Yes.
Right, okay, what do we do?
These all get bolted like a giant ladder down the side of the wall of the pier, yeah?
Right.
And then the pipe sits in between the uprights.
Oh, I've got a piece of pipe, actually. This is part of my funnel.
Yes, good. You can see it better now. All these are going to be tied together with big lumps of angle iron. Yeah. And the pipe's going to be held in it.
Right.
These fat straps.
It's heavy. Getting this over the edge of that sort of pier wall is going to be hard. I'm going to stick this onto my funnel, and I'll come back and give you a hand, yeah?
Thank you.
5 layers of fiberglass later, Dick's funnel is finished and ready for a weatherproof coating. He thinks he's made it strong enough, but there is one concern.
You ready for launch yet, Dick?
Do you want to know something? If we don't attach this to the top of that tube properly, it could go anywhere.
You've got to make sure that that join takes the full force of the air coming up there.
It would be embarrassing if it took off, wouldn't it?
The funnel will need lots of bolts to hold it securely on top of the pipe. Otherwise, when a big wave hits, the huge increase in air pressure could blow it off.
That's the reason why we're making it as strong as we've made it. Like.
It's great. It's absolutely great. It looks like something out of the Science Museum, but it's absolutely great.
Agree with that.
Cool. I'll get the rest of my bits ready.
Jem's gigantic frame is ready to be assembled. It's made of hundreds of kilos of metal, but it's only when it's fully laid out that Dick and Jem can appreciate its true size.
What have you done? Look at all that metal. It's massive.
I don't even know if it's big enough. No, that's... I mean, like, looking at the sea, how big do you make something just as big as you can?
That is big. Lots of welding still to do?
Yeah, and then we drop the pipe in and good to go.
They want to complete the main structure of the oscillating water column and install it at the pier tomorrow. The plan is to get that out of the way before starting the parts that will generate electricity and be added to the top. So, with the pier reserved and a crane booked for the morning, will they finish on time? Next morning, the main structure is finished and ready to attach to the pier. Surfers Keith and Rosie are here to help load up. With a big day ahead, a bit of brute force gets the mission underway.
1, 2, 3.
Yup, Jem.
Swing this on here.
That could be the last time this thing's ever on dry land.
It might also be the last time it's ever in one piece if the weather they had here last winter strikes again. Fortunately today, the Atlantic lies quiet, as if permitting Dick and Jem to proceed. The operation rolls into action. The crane, safety boat and council permission have all taken careful planning, so there's a lot resting on today. However, what could spoil it is the tide.
We've only got till 15:11. That's the low water mark.
Fitting that bottom part of the frame, we've probably got about 15 minutes to do it, and that's it. That's it.
Get on with it.
They can only bolt down the bottom of the frame when the tide reaches its lowest point, meaning they'll only have a narrow window of time before the water starts to cover it again. With low tide approaching, they need to get cracking, and the funnel still has to be attached to the end of the pipe.
Keep tightening. Just let me know when you're going to drill anything.
Coming through somewhere above your head, Jem.
Yeah, and move back.
Just over an hour to low tide, and the installation begins. It's a tense moment as the heavyweight frame starts being edged into position.
I would say that's not far off there. Mind yourself, Jem, we've got the horizontals coming in. That's it down as far as it's going, isn't it? It maybe come out to sea slightly. Right, so I want to go out that way, so up a little bit and out that way.
Despite the time pressure, they can't rush this. It's a hazardous job and has to be positioned exactly.
Sweet. Yeah, that's ideal now. It's sat really nicely.
The bottom is just in the sea. The water's still going down, so at low tide, it should be high and dry and clear to bolt in.
Got about an hour, I think, before the tide's at its lowest. So.
Tide and time wait for no man, mate.
When these holes have bolts in, the frame will be secure, enabling Jem to climb up from the bottom and drill the remaining holes.
Dick, I'm going to come down and do the bottom ones.
Good call.
I don't know if you can fire in those.
Yeah, so I'll get
it might be a bit tricky, but give it a go.
It's still a few minutes before low tide, so Jem makes a start on the fixing beam next up from the bottom. The holes must be 15 centimeters deep to stop the bolts pulling free. So if they hit very hard concrete or metal reinforcing underneath, the job could easily be held up. The next task is to inject an adhesive resin into the holes. This gives a chemical anchor for the bolts that will be stronger than the concrete itself.
Jem, 10 minutes till low tide, mate.
All right. I'm going in to do the holes.
The bottom of the frame is only just clear, but Jem decides to go for it.
No, the water's just washing right over us.
Minutes later, and it's officially low tide, but there's still hardly any clearance. They're right on the limit of being able to drill the holes.
This is as low as the tide's going, mate.
Like, can you keep an eye out for any big waves that are coming? Just swamps the lot.
Wave!
Jem can't risk the drill flooding. It'll break and could give him an electric shock.
Wave! That was a big one. Wave! Wave! Wave!
Right, that's it.
Well done, mate.
After a frantic 5 minutes, Jem still has to inject the holes and set in the bolts. Luckily, the resin compound does work underwater.
How are you doing for that tube? It's nearly empty.
Right, empty.
Yeah, it's setting quite quickly, mate, so you need to get used.
With the sea only getting deeper now, up above, Dick begins hoisting up the pipe ready to lower it into the frame. Not a moment too soon, Jem tightens the final bolt.
Dick, that's it.
Down and clear, Jem.
But they're not out of the water yet. The final task before the tide rises too high is locating the pipe and clamping it down at the bottom.
Right, we need to rotate it. It needs to... Hold on. Now, can you rotate it by hand? Yeah, okay. Oh, okay, like that. Okay. Right, you're pushing in. That's it. Good man.
They've beaten the tide, and their impressive installation has drawn quite a crowd of local supporters. So once the pipe is strapped in tight, they can stand back and admire their handiwork.
We were seriously lucky with the weather and things, weren't we?
Yes.
Isn't it beautiful?
It's fantastic, Dick. Come on, Neptune.
A little later and the tide is up, but the big question is, do the waves push the air up and down in the pipe?
That's so cool.
Well, hold on. We have to... Way up!
So a major milestone is achieved.
It works.
It does work, you see.
But there's still lots to do. Turning the waves into electricity for the caravan. Next morning, the hard work has paid off. The oscillating water column has survived the night. Keith and Rosie are at their caravan, getting ready for a touch of surfing. But Dick and Jem can't afford to relax. They still face the challenge of getting their pipe to produce power.
Right, we've got wind coming out of our funnel. Now what we have to do is we have to turn that into electricity. We need to scale up something like this that worked on the bucket.
We can make some blades of powder steel.
How long do you reckon it'll take?
10 minutes.
Jem's going to rustle up his own wind turbine. The turbine will be mounted on the funnel of their oscillating water column. The moving mass of air inside the pipe will simply push on the rotor blades, creating rotation. By attaching the turbine to the spindle of an electric generator, it will produce electricity for the caravan. By changing the angle or pitch of the blades, it affects how easily the turbine starts up. The steeper they are, the less wind is needed, although the maximum speed will be lower. Coupled up to a 12-volt generator, the turbine's ready to be tested.
That's nice. That's a nice wave. I reckon we would need about 8 meters a second to really spin up.
We'll see what's coming at the end of our tube. This is quite exciting now, you know?
It is. It's a bit of a big moment.
When the turbine and generator are spinning, it'll charge a battery for the caravan. Question 1 then, will it spin?
Hold it in there.
Whoa! It goes, Dick, it goes! I feel like Dr. Frankenstein. That's amazing!
Look at the size of that wave!
Oh, come on.
Here, hold on.
It's encouraging stuff. But more importantly, is it making electricity?
4.45!
Oh, minus 3.5! Oh, my plus 3!
That's a screaming turbine!
It's a fantastic result, and it's proof that their wave energy concept works. However, they're not getting the 12 volts needed to charge a battery for the caravan. The turbine has an inherent problem.
You lose so much, though, as it swaps from one direction to the other, on the pull and the push.
So you just about get up to speed, you make good electricity, and then it tries to change direction.
The oscillating water column not only blows air upwards, but it also sucks air down as the wave falls away. That means Jem's turbine is constantly stopping and starting up again in the opposite direction.
What we really need, Jem, is I think we're going to need a turbine which goes the same direction when the air comes up and when it goes back in.
Yeah.
The difficulty is, where are we going to get one of those?
I don't know, you're Irish, Dick. You know the lie of the land.
Dick is referring to something known as a Wells turbine. This is a precision-engineered piece of kit that has blades which spin in the same direction no matter which way the air is blowing. By using one, they could hugely increase the electrical output of their water column. Trouble is, Dick and Jem don't have the resources to make one of their own. But as luck would have it, Wells turbines were invented in Northern Ireland. So Dick does some research.
Belfast is about 10 miles from where I used to live. You make a phone call and you never guess what. I've tracked one down.
You've pulled in your old town contact.
Yeah.
Dick, you're a star.
But having tracked one down, they don't know if it's going to work. Yeah, it's a
Right.
prototype.
And they've got actual turbine blades.
Yeah.
While they wait for the Wells turbine, Dick and Jem have an extra project for the surfers' caravan, which could be adopted by outdoor adventurers everywhere.
Oh, it's just we wanted power,
Fire, electricity.
not a bike.
Now, you two need to get used to using this, all right? It's not that difficult, is it?
No, you're fine.
No, it's dead easy. There's helmets. While you're practicing that, we'll build something.
Here you go.
The plan will allow Keith and Rosie to head to the remotest of beaches. A bicycle-powered generator for two. To produce electricity, they're going to make use of the curious fact that an electric motor, like the one on this scooter, can also be used as an electric generator. Generally, with motors, you put electricity in and get movement out. However, you can actually turn that idea on its head and put movement in and get electricity out. It's all hands to the pump building the bicycle generator. Keith's putting stunt pegs on the tandem. Rosie's preparing the frame to be welded by Jem, while Dick gets his teeth into any metalwork that's going. And in no time at all, it's ready to test.
Sorted.
For the moment, they're connected up to a small bulb.
Rosie, you know the rotor. It's your turn tonight. Yay! Rosie!
Rosie, we're putting a cup of tea on. We won't be long. Keep pedaling.
Almost everyone can enjoy caravan illumination.
Rosie!
Dick and Jem have now got their hands on the piece of precision engineering that is a Wells turbine.
It's got the perfectly symmetrical aerofoil. The air gets sucked up, gets diverted by the wing and sent back that way, which pushes it forwards. And then when it comes down, it hits there, gets diverted round and keeps pushing it forwards.
The aerodynamic blades on the Wells turbine mean it only spins one way, even if the wind direction changes. This is a snapshot of a spinning blade, with wind coming up from the bottom. The blade divides the airflow disproportionately, so most of it travels back along the underside. Because only a small amount of air goes up around the front, the blade is pushed forward. If the wind in the pipe then changes direction, the top of the spinning blade now experiences the disproportionate flow. The turbine will continue to spin without stalling, generating electricity continuously. What's also useful is the turbine's close fit inside this tube.
With turbines, obviously, like, if they're close to the edge, they're very good. If they're pretty much touching the edge, they're brilliant.
Jem sets to work modifying their generator so the Wells turbine will fit onto it. Dick's devising a way of mounting the turbine and generator in the yellow tube.
Let's go and fit it in the pipe.
Did that appear with it?
It's time to fit the Wells turbine and generator to the funnel. This is a make or break moment. Will the airflow spin it up or blow it off like a cork? The Atlantic swell around the bottom of the oscillating water column should be enough to send a powerful wind whistling up the tube. So everything's resting on whether the Wells turbine will do its thing.
Yes. Let's get it on there.
The moment it's on, they can hear it working.
Ooh,
Get it attached, Jem. I'm holding it in a minute.
All right, all right, all right.
Outside one now.
If I slacken this up a little bit.
It's breathing away.
It sounds like a sleeping dragon, like some Irish sea dragon, and every now and again, it's going to wake up like this when this comes in.
What do you think it is? Oh, it's humming.
Oh.
I think it's purring. It's
is.
content.
Yeah.
It's doing what it's supposed to do. Harnessing the waves.
See, it does keep going the same way regardless. I love it.
It's a success, no matter whether the air is sucking or blowing. And they're also impressed with the amount of wind coming up their column.
I happen to have an anemometer for measuring the speed of the wind. Here we go.
What speed do we get?
Yeah, get up there.
26, 30! 30 miles an hour. 30 mile an hour wind through there is good.
So with the electricity flowing out, they waste no time connecting it up to a battery system. A gadget called an inverter will step up the battery output to mains voltage. And everything's enclosed in a tough weatherproof box to protect the electrics from the elements. The power will travel down a chunky cable all the way to the caravan, where surfers Keith and Rosie are eagerly waiting.
Oh, they're looking chilled. Here we go.
Oh,
Put a connector on this, connect it up. You got wave power.
yeah.
Happy days.
Then once you're plugged in and the batteries are charged, it'll be lights, music, action.
Right, get the beer.
The big switch on is next, but only after a good few hours of battery charging. As the sun goes down, it's time to get ready for the test.
You have to get on there. We're on the case. Pull it your way, Jem.
Yeah.
The moment of truth. Will the oscillating water column have produced the goods?
We've now got power at the end of this cable.
Is there enough juice to light up the caravan?
Do you reckon it's going to work?
Yes, I reckon it will. Get it in there, Dick.
Here we go.
This bit goes in there like.
Oh.
Here we go.
You haven't left the gas on, have you?
It's a fantastic success. In just a few days, using some old sewage pipe and some makeshift materials, they've harnessed the Atlantic and turned its waves into Maine's electricity.
Here's to Irish waves.
Today it's a caravan, but tomorrow machines like this could really catch on and generate power for coastal communities all over the world. Another job well done for the Planet Mechanics.